Hello, so welcome to my second flight with the Haohan Firefly. The main objective with this flight was to get some current sensor readings and get that tweaked, and obviously do a few little stall tests and things like that. If you saw my maiden video, you would have seen some very high current draw. The reason for that is the flight controller supplied by Haohan. It's a one made by Baldwin RC, I think that's the name of the company, and although it uses the Maytec F405TE target, the Maytec defaults for current sensor readings were wildly off. I used Mr. D's very clever little current sensor calibration tool on a watt meter and recalculated the scale and offset, and this is now reading pretty much spot on, and conversely the current readings now are considerably lower than they were before. It's worth noting with this flight controller as well that although I haven't had any issues with it, there were a few sort of errant solder blobs on one of the pin rails, and Giz has had an issue with his where the 9V BEC supplying the VTX, although it was supplying almost 9 volts, it was supplying basically no current, so it wasn't able to run his VTX. So it remains to be seen whether or not QC improves with that. I hope they do, because in all other regards it seems quite a nice little flight controller. But yeah, let's say call these teething issues now and see what happens. So I've just been flying around in cruise mode, and this was to get some readings for watts consumed and an average cruise speed, just using auto throttle. And using that and a few other tweaks and calculations and settings, we can have battery estimation using watt hours rather than the mAh or milliamp hours, which provides a far more accurate way of measuring current draw and obviously remaining capacity in the batteries. You'll notice that obviously I've got the battery percentage in the top left hand corner. Currently it just dropped down to 91%, so that's obviously counting down. That should be accurate now because I've put all the values in. I will put a link in the description to Mr. D's page talking about converting over to watt hours. Well worth doing and having a look into. Takes a bit of getting your head around converting from mAh to watt hours, but once you've done that, it will provide a much more accurate idea of how far you can push things, how much power you are actually using irrespective of the voltage changes, and it's just a better system overall. Underneath the battery percentage you can see 3 dashes. That would normally tell you your remaining flight distance, which if you're doing for long range flights is quite handy to know, because you can then work out whether or not you're going to make it home or not. The reason it's showing 3 dashes at the moment is I haven't added in the data the flight controller needs to calculate that yet, and that's part of what I'm doing on this flight, is getting those watt readings and average speed readings and cruise, so I can add those values in, and then on the next flight we'll see that will show a remaining flight distance. I'm now going to start doing some stall tests, so this is where I'll drop the throttle and we'll see if we can get this to stall. So I think it's around about here I start doing this. Sorry, I am narrating this after the flight, so you'll have to bear with me. I think it's around about here I start doing some stall tests. Maybe not. So I do that at some point anyway. And interestingly, there was no tip stall whatsoever. I sort of raised the nose and cut the throttle, and it just, the altitude just dropped. It didn't even nose down drastically. The part of the design brief from Haohan is that they've added in some wing twist, with the idea being that in a stall scenario, this is where I'm doing the stall test, so you can see I'm pulling back, cutting the throttle down, and it just drops. So cut the throttle now, and it's just losing height, but it's, this is 0 throttle now, putting full back on the stick, and there's no dropping of the wings, we're just losing altitude. So even banking, I wasn't really able to get any stall happening. That was me banking rather than a wing dropping. So very, very good stall behavior. And yes, as I was mentioning, they've designed in a twist to the wingtip, with the idea being that in a stall scenario, the inner part of the wing closest to the fuselage will stall before the wing tips. So you'll lose height, but you won't lose control surface control. There'll always be enough airflow flowing over those. Trying a bit of inverted flight there, did that remarkably well, and despite the design, it is reasonably agile as a plane, surprisingly so. Obviously, having the sort of the fuselage, battery bay, and pod, quite low down, you'd think that it would be really lazy to roll and sort of flop over and rolls, but it really doesn't. It's surprisingly nimble. It's not the fastest plane, but I don't think it's really designed to be. It's designed to be an efficient cruiser and very quiet, and really it is designed to be I think really it's designed to be a surveillance platform. So you've got the nose with the gimbal option there, and that's what it's really just built for. So you can just get up to altitude, throttle back, and cruise, sipping the watts, and use the gimbal to look around. I will add my gimbal to this at some stage, so we can use that as well, but just for these first test flights, I've only got the FPV camera in there as a reasonably temporary solution. I just wanted to get it all dialed in and flying nicely and landing safely before putting my gimbal in there. But first impressions are I'm pretty pleased with it. It is worth noting that although I've had no issues with landing, both Giz and Bonafide Pirate have flipped theirs on landing, and the difference between the way mine is set up and the way theirs is set up is I'm using the FPV nose, which has a sort of a foam insert, and they are using the gimbal nose, which is much more open. And we have a sort of a running theory that perhaps the more open mouth-like nose designed for holding the gimbal is actually catching on the grass when landing, and that causing that sort of to cause the grab into the grass and cause a flip, whereas mine with the foam insert is just sort of skidding along the ground and not catching in. And it's doing a low pass here as well, so this is moderately high throttle, sort of coming in about 100 kilometers an hour. Does seem to be a little bit of a wobble here. I don't know if this is just sort of picking up on some turbulence nearer the ground, or if there is a bit of a yaw wobble at higher speed. So that will be something to test further. My CG is pretty much on the marks, and I've not added any weight, and the battery is all the way to the front. I think it's designed naturally to be able to carry a reasonably heavy load up front, obviously to feature in that gimbal and a larger battery pack. I'm only using a single 4S lithium-ion 21700 pack in this flight, so I'm flying this pretty light. So yes, it remains to be seen how that behaviour sort of manifests itself, whether or not it was just an anomaly on this day, or if there is in fact a bit of yaw waggle at higher airspeeds. I'm coming on here. Well, this was intended to be a landing, and as I got into ground effect, it just would not slow down. I cut the throttle some time ago, and it's just not slowing down, so we had to bail out of that one, and we'll have another go around and try and make it less of a hash of it the second time round. So my plan was to fly out a little bit further and come in at a lower altitude and just slow it down that much quicker. But it certainly does seem to carry the momentum quite well, despite the large fuselage and the relatively short wings. I don't think I've mentioned yet, this is only a 1080 millimeter wingspan, so it's not the longest wingspan. It's a slightly smaller wingspan even than an Albert with a much narrower wing chord. But despite that, it generates a lot of lift, and it seems to glide reasonably well. So yeah, we're having a final approach now, and I think I start cutting the throttle, or at least lowering the throttle before we get over this last hedge. So just coasting it in, really. I'm landing this one in angle mode for laziness more than anything. It flies perfectly well in acro, but I just felt like being lazy and letting it self-stabilize and just focusing on pitch. So yeah, cut the throttle now, just glide it in and flare, and we're down in one piece. And you'll notice that mine didn't grab and flip over, and it could just be down to that nose. And here are some nice post-flight stats for you to look at. That's all from me. Thanks very much. Bye.